10.3 is on circles. Circles are nice and fun and simple. You've played with circles before, but now we'll do them with equations on coordinate planes. A circle just needs a center and a radius. That's really all there is to it. Once you have a center and a radius, you can draw your circle. Sometimes h and k will move the center of your circle to the point hk, but all you gotta do is find the center and graph it. So this one down here, the center has not been moved. So the center of this circle right now is 0, 0. It's the point 0, 0. Now this number here is not the radius. That is r squared. If r squared is 25, then the radius itself is just 5. So I know that from the center, I'm going to go right 5, up 5, down 5, and left 5. And you can try to draw your circle here. If you have a compass, you can definitely use a compass. But here's a really great trick that I have for you, one that you're going to want to remember, just because it's nice. It's not actually going to make a difference anywhere, except for the graphing gets much easier. I know these 4 points I have here are good. These are up 5, down 5, left 5, right 5. And the trick is that I take the radius and divide it by the square root of 2. That gives me the decimal 3.53. That decimal 3.53 tells me how many diagonals to count out. 1, 2, 3.5 diagonals. 1, 2, 3.5 diagonals. 1, 2, 3.5 diagonals. 1, 2, 3.5 diagonals. And once I count out those diagonals, once I count out those diagonals, my graph is going to get much easier for me to freehand draw. I've got more points to look for. There, and like there. That's still not a great circle, and you're going to spend most of your time when you draw your circles hating the circles that you're drawing. So a perfect circle would have looked like that. But it's not bad, you get the idea. Okay, next one. The center on this one has been moved. The h and the k are present. This has an h value of 2 and a k value of 3. So my circle is at the point 2, 3. That's where the center is. Now the radius is again 5, not 25, but 5. So I'll do my up 5, right 5, down 5, left 5. And I can do my same diagonals, 1, 2, 3.5, 1, 2, 3.5, 1, 2, 3.5, 1, 2, 3.5. Try again. That one also looks fairly poor, but probably better than most of the ones you're going to draw, you little brats. Yeah, see? That was actually a pretty good circle. If the radius was something like 9, then I would do square root of 9 over 2. Oops, excuse me. So to find those diagonals, just take whatever your radius is and divide it by root 2. Sorry, 9 divided by root 2. Here's a big secret. The equation of a circle is really just the distance formula. I mean, here's the distance formula right here. And if I were to take my circle equation and square root both sides, this just turns into this. Which makes perfect sense because what a circle is doing is taking all the points that are the same distance from a given point. Now there's an even worse circle. Taking all the points that are the same distance from a given point. So this is just every possible point that has this distance from the point hk. Here, this is a fixed point. These are fixed points, like they always stand for specific numbers. So you're calculating one distance. But because this right here is a variable, x and y are variables that can change, they're not fixed, you're finding every possible point that has a fixed distance. And remember, the distance formula was really just the Pythagorean theorem. I mean, look at how similar these look. This is really your horizontal distance, that's your vertical distance. A squared plus b squared is c squared. Okay, write the equation of this graph. To do the equation of this graph, I have to know the radius. The radius of this graph is very clearly 3 units. So I can just do x minus h squared plus y minus k squared equals r squared. So r squared is 3, this is a 9. And this is the point 3, 2, that's where my center is. So it's x minus 3 squared plus y minus 2 squared equals 9. Beautiful. Next. The endpoints of a diameter are 5, 2, and 12, 6. Write the circle's equation. Well, the only way that I can possibly do this is to first find the distance between those 2 points. I have to actually find the diameter. So if I do 12 minus 5 squared and 6 minus 2 squared and square root all of that, I'll get the distance. Well, that's 49 plus 16, and 49 plus 16 is 65, which is going to be just a little bit bigger than 8. The diameter has a distance of 8.01, I'm guessing. 8.06. Well, if that's the diameter, the radius is going to be 4.03. There's my radius. The other thing I have to find is the center. To find the center, I need the midpoint. Because obviously, I'll draw a nice little picture here. If I have a diameter, I need the radius, which is going to be half the distance of the diameter, but I also have the center, and the center is going to be the midpoint. So the midpoint formula is going to give me 5 plus 12 over 2, comma 2 plus 6 over 2. It's a point with an x and a y coordinate. So 17 over 2 is 8.5, 8 over 2 is 4, that's my center. My center is a point 8.5, comma 4. So I'm going to have x minus 8.5 squared plus y minus 4 squared equals 4.03 squared. And 4.03 squared is not 8.06. Please don't try and get into that little habit of doubling things again. It should be 16.25. So it's really going to be x minus 8.5 squared plus y minus 4 squared equals 16.25. There's the equation of the circle with that endpoint. Yay. Graph this. Alright, now this one is not in a form that I know the center right away. So I have to find the center. And this involves completing the square twice. I'm going to complete the square twice. I'm going to get my x's together and my y's together. I'm going to take that 3 and move it over. Add 3 to both sides. I'm going to complete the square with this. So I'm going to have x squared minus 6x plus 9. Since I added a 9 here, I can subtract 9 here. I'll go for this a little bit slower actually. This right here is one of my b values. I have a b value of negative 6 from this. Well, then b over 2 is negative 3, and b over 2 squared is going to be 9. So, I need to add a 9 here. When I add that 9, I need to add 9 to both sides of the equation. So I add a 9 to one side of the equation, and I add a 9 to the other side of the equation. And that's what this is supposed to be over here. That came from here to here with it. I can do it with the y's also. This y has a b value of 4. I'm doing these y's here, b value of 4. So b over 2 is 2, and b over 2 squared is again 4. So I'm going to have y squared plus 4y plus 4. So I added 4 to this side, I added 4 to this side. Well, now I can factor. This factors into x minus 3 squared. This factors into y plus 2 squared. And this becomes 16. And how nice it now worked out to a perfect square. So now I have a center at the point 3, negative 2. A radius of 4, because the square root of 16 is 4. So I'll go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then I'll do my diagonal trick, just to get a prettier graph. Do 4 divided by the square root of 2, and that's 2.8. So we go 1, 2.8 diagonals, 1, 2.8 diagonals, 1, 2.8 diagonals, 1, 2.8 diagonals, and then try to draw this circle. Not very good. A little bit better. Again, I can be sneaky and actually draw a perfect circle like this. And you see mine wasn't too bad, a little bit shallow on the top right. If you have a compass when you're doing your homework, use your compass and draw nice circles. You'll be glad you did, it's worth it. I think that takes care of everything. There's your graphs.